Good afternoon, everybody. My name is Ken Collins, and I'm here representing Skkynet Cloud Systems. And I'm going to walk you through a video that introduces our platform for delivering secure end-to-end solutions for real-time data. Focuses on real-time. I think a lot of us understand the problem is fairly easy to understand, assuming the video is playing. There we go. The problem is that we've got industrial systems or maybe financial systems, and we want to be able to push that data, to share that data with other systems, or maybe view that data through a web browser in a remote location. And at times we need to acquire and aggregate that data and share it, mishing and mashing for more intelligent consumption. Some of our customers they need solutions for the latest in embedded systems and standalone devices, or maybe they want to leverage an existing traditional Office decision support system into new areas. And of course, we want to do all of this in the cloud. And that introduces a whole new set of concerns, from security and speed, reliability, remote access, collaboration, and ease of use. And these challenges are difficult to address. Firewalls, for example, are absolutely critical, but they make remote access and collaboration much more difficult. Is that still playing? There we go. There we go. We feel we have a solution. Today, we are actually announcing the general availability of our secure cloud service. And I want to explain how this works. First of all, we need to protect our systems. Our key systems have to remain protected behind our firewalls, behind firewalls in particular with no open inbound ports. Well, the Cogent Data Hub is an established middleware product that focuses on the acquisition, aggregation, and distribution of real-time data. For embedded systems and standalone devices, we can offer you our embedded toolkit. Both the Cogent Data Hub and the embedded toolkit work with your existing systems. They are easily configured to sit behind the firewall and handle the distribution of that real-time data. The key here is no open firewalls. So we are able to establish outbound connections only out to the cloud with absolutely no inbound ports open in the firewall. What's the key to that? Well, the key is that secured by design, this means there is no attack surface for hackers to exploit, no open firewalls. Connections are initiated outbound only and only by your systems. But once a secure connection has been established, data can flow in both directions through that web socket. Okay, so we have a secure outbound connection with bidirectional data flow and control. Other components of our system that you'll hear me talk about, in addition to the Skkynet Secure Cloud Service, is we've got Skynet WebView, that is our solution, our HMI builder, if you will, and the Skynet portal. And that's used to administer the service, managing user priorities, configurations, those kinds of things. Let me give you a demonstration of how this works. So we've got a plant running in Japan. Now, for the purposes of demonstration, it's really just a virtual machine, but it really is in Japan, and it really is behind a secure closed firewall. We've installed and configured the Cogent Data Hub to push data in real time. In this situation, I've got a single wind turbine that's generating data, and you can see up here in the Canventus domain, it's pushing data, it's generating data. We want to push that data out into the cloud. So we go to our Skynet portal, and we register, we configure our service. The portal allows you to choose from a number of different service levels to address your needs for data isolation, process isolation. Each organization has their own DNS. Each organization has their own data context. And there's a comprehensive suite of tools for managing authentication, authorization, so you've got different permissions for different sources of data. I'm going to go back to the Japan plant, and I'm going to configure a bridge or a push of that data. I'm going to use the organization DNS. I'm going to use the credential that I just created. And so I enter that information there. You can see I need to indicate what the local data domain was, the data domain that I want to push data to. We're using industry standard protocols, so we've got WebSockets, SSL support. I use the same credential there that I configured in the portal. And as soon as I now come back and hit apply, you'll see the status here change to running, which means we are now pushing data out into the cloud that quickly. I'm going to go back to my portal. I'm going to click my service URL. That's going to launch Skkynet WebView. Skkynet WebView is our HMI builder that is an integrated development environment running in the browser. And so whether it is labels and text boxes or gauges and trend charts, we've got complete design over the complete control over the design process. And you can see that's all it took to bind that to real-time data. Indicate your context, indicate your data point. There it is. So I can add lots of different controls. We've got hundreds of controls and thousands of different symbols. Right now, I'm binding some controls to that wind farm data, and I want you to watch. We're going to go into run mode, and you'll see that I'm able to not only see the data in my controls, I can interact with the data behind the plant firewall, even though it's totally closed. So I'm going to add the rate of data generation. I've got a little checkbox there called auto mode, and when I go into run mode, there, you'll watch up here right now, the set point is it's a PID controller, and you can see that it's changing about once every 5 seconds. I turn off auto mode, and my data starts to stabilize. That is changing the data in the plant behind the firewall through the web browser with a publicly available link securely. Okay? So you can see that right now I changed the frequency rate. Now my source data is being emitted from the plant only once a second. Just reorganizing the screen here a little bit, I'm going to bring back the data source, my PID controller running in Japan, and so it's now running on the left, and on the right, I've got my system. Watch as I click the checkbox for auto mode and how quickly it changed on the left. Watch as I change my frequency from 1 to 5. You can see where the 1 is, and as soon as we enter the 5 and hit enter, over there in Japan, that's the other side of the planet. That is not a simulation. That is in real time right there. Okay? I hit pause on my process data in Japan, and it immediately had paused. Okay? Just rolling forward a little bit, I talked about lots of different controls. So you can see we've got trend charts and lots of stuff. Over here on the top left, I've got a map, and I'm using that as a selector. So you can see I've only got one wind turbine running, the yellow-green one. The others are off. I'm going to use that as a selector to update the other controls. I go back to Japan. I shut down that one wind turbine, and I'm going to run a different program to start up 7 different wind turbines so I can push and aggregate multiple sources of data. I come back, and you can see those wind turbines starting up. And as I hover over a push pin and I click, the other controls update. And that includes, for the first time, you can see WTA 6 and 7 there are generating real-time data, but managing that in the historian back on the server. So as soon as the server recognized that it needed that data, it immediately started to collect that information. Okay? Our solution, like Skkynet WebView, like all the other components of our solution, are very extensible. So you can use the integrated script library to create some very interesting user experiences. All controls are configurable and fully extensible. You can even create your own controls, symbols, and script libraries. In this example here, it's a water treatment facility. You can see lots of different controls and choosing from among over 4,000 different symbols. Every one of them can be bound. Anything can be bound to anything. In this example here, we've got a wind turbine that we built for one of our customers showing the detail of what's going on in real time. And again, you can see just through some very simple design techniques and a little bit of scripting, you've got some very nice, powerful, real-time dashboard capability here. Let me just kind of summarize what we are looking at here and what we've seen so far. On the left, I have another virtual machine running in Ireland, and it's got the same WebView page that we had open, and on the left, I've got my development machine in Canada. Watch as I click on the auto checkbox on the right, and as I drag my gauge back and forth. Those things are virtually updating at exactly the same time. That's real-time data. And keep in mind, folks, this is not peer-to-peer between Ireland and Canada. All of that's going through Japan, because that's the source of the data. And so as I click pause in Japan, everything stops. As I resume, everything continues. What you've seen there so far is kind of machine to visualization or machine to user. This show is machine to machine. Well, think about it for a second. We need the capability, not just machine to visual, but here on the left I've got my same plant in Japan, but this time I've got my partner plant in Brazil. And within 5 minutes, I installed the Cogent Data Hub. I opened up a connection. I pushed my data out into the cloud. You can see that I've got the same connection that I was using before, using SSL, WebSocket, whatever I want. Right now, in Brazil, you'll notice it's going to show you the data browser. It should be up here in a second. It's not on just yet. Hold on. There we go. So you'll notice the absence of Japan WF. There's no data over there yet. As soon as I come back over and I click Apply, watch how quickly that data starts. You saw it go running. There's my Japan wind farm data. That's real time from the other side of the planet. So machine to machine. So we've got the ability to have one plant on one part of the world communicating in real time with another, bidirectionally data flow and control. Both plants are securely protected, absolutely no open firewalls. We talk about the Internet of Things. Well, we need to make sure that we are thinking about the things. So I mentioned earlier the embedded toolkit. Embedded Toolkit, ETK, is freely available source code that you can use to help establish that outbound push to connect your devices directly to the cloud. We've got our team in Japan, a bunch of engineers. They've tested the ETK with a number of different devices. And regardless of the source of data, you can, once you push it up into the cloud, you've got access to WebView or whatever other tools you want to build those visualization solutions. This last demo that's coming up really pushes the envelope a little bit. One of the engineers back home decided he would go out and buy a Parrot AR drone remote control helicopter. He built a little device driver because, of course, it's not just the Internet of Things, right? We believe in the Internet of fast things. He goes out and he builds a little device driver, connects it to the cloud, and within minutes he's controlling that remote control helicopter through the computer. Okay? Let me make sure that you understand what you're seeing here. I just want to pause this for a second. The laptop and the helicopter are running just outside the Toronto area in Ontario, Canada. Our cloud service is in Virginia in the United States. That's a 1,000-mile round trip between his fingertip and the copter. That is fine-grained precision and control. Okay? Both the device, the client, and the service are all protected. Okay, and you can see that, I don't know. For me, that's real time, and that's cool. As we open our exhibit hall tomorrow, please drop by and visit our booth. We don't have our helicopter with us, apologize, but we do have lots of demos and lots of really interesting information. You can even use your phone to play with a functional SCADA system connected to a B&B mobile router, which in turn is connected to the secure cloud service over an LTE network. And we can show you how to connect all those systems securely. Thank you very much.